5. Quantifier specification. So, how do we symbolize there is some person who hates everything? First, we must choose a universe of discourse that is large enough to encompass everything that we are talking about. In the context of intro logic, if we are talking about anything whatsoever that is not a person, then we must set you equal things. In that case, we have to specify which things in the sentence are persons by employing the predicate, is a person. The following paraphrase makes significant headway. There is something such that it is a person who hates everything. Now we have a sentence with uniform quantifiers. Continuing the translation yields the following sequence. There is something such that x it is a person and px and it hates everything yhxyxpx and yhxy. Let's do another example much like the previous one. Everyone hates something or other. This means every person hates something or other, which can be paraphrased pretty much like every other sentence of the form every A is B. Everything is such that x if it is a person, px then it hates something or other yhxyxpx yhxy. At this point, let us compare the sentences. There is something that hates everything xyhxy. There is some person who hates everything xpx and yhxy. Everything hates something or other xyhxy. Every person hates something or other xpx yhxy. The general forms of the above may be formulated as follows. There is something that is kx. There is some person who is kxpx and kx. Everything is kx. Every person is kxpx. We have already seen this particular transition from completely general claims to more specialized claims. This maneuver, which might be called quantifier specification, still works. Everything is bx, every A is bx something is bx some A is bx and bx. Quantifier specification is the process of modifying quantifiers by further specifying or delimiting the domain of discussion. The following are simple examples of quantifier specification. Converting everything into every physical object, converting everyone into every student, converting something into some physical object, converting someone into some student. The general process in the special case of a simple predicate P is described as follows. Simple quantifier specification where V is any variable, P is any one-place predicate, and F is any formula. Quantifier specification involves the following substitutions. Substitute VP VF for VF. Substitute VP V and F for VF. Note carefully the use of in one and N in the other. Examples: something is evil x, some physical thing is evil x, px and x. Everything is evil x, every physical thing is evil x, px. Someone respects everyone x, y or x, y. Some student respects everyone x, s, x and y or x, y. Everyone respects someone x, y or x, y. Every student respects someone x, s, x, y or x, y. So far we have dealt exclusively with the outermost quantifier. However, we can apply quantifier specification to any quantifier in a formula. Consider the following example: everyone respects someone or other xy or xy versus everyone respects some student or other. In applying quantifier specification, we note the following. Overall formula y or xy specified quantifier y specifying predicate psi modified formula rxy. So applying the procedure, we obtain resulting formula y psi and rxy. So plugging this back into our original formula, we obtain everyone respects some student or other xy psi and rxy. The more or less literal reading of the latter formula is for any person x, there is a person y such that y is a student and x respects y. More colloquially, for any person, there is a person such that the latter is a student and the former respects the latter. Still more colloquially, for any person, there is a person such that the latter is a student whom the former respects. We can deal with the following in the same way. There is someone who respects every student. This results from there is someone who respects everyone x, y or xy, by specifying the second quantifier, as follows. Overall formula y or xy specified quantifier y specifying predicate psi modified formula rxy. So applying the procedure, we obtain resulting formula y psi rxy. So plugging this back into our original formula, we obtain there is someone who respects every student x, y psi rxy. The more or less literal reading of the latter formula is there is a person x such that, for any person y, if y is a student, then x respects y. More colloquially, there is a person such that, for any person, if the latter is a student then the former respects the latter. Still more colloquially, there is a person such that, for any student, the former respects the latter. So far, we have only done examples in which a single quantifier is specified by a predicate. We can also do examples in which both quantifiers are specified, and by different predicates. The principles remain the same, they are simply applied more generally. Consider the following examples. 1. There is someone who respects everyone. 1. There is a student who respects every professor. 1b. There is a professor who respects every student. 2. There is someone who is respected by everyone. 2. There is a student who is respected by every professor. 2b. There is a professor who is respected by every student. 3. Everyone respects someone or other. 3. Every student respects some professor or other. 3b. Every professor respects some student or other. 4. Everyone is respected by someone or other. 4. Every student is respected by some professor or other. 4b. Every professor is respected by some student or other. The following are the corresponding formulas. In each case, the latter two are obtained from the first one by specifying the quantifiers appropriately. 1x, y, rx y1 axs x and y pi rx y1 bx px and y psi rx y2x, y, rx 2 axs x and y pi rx 2 bx px and y psi rx 3x, y, rx y3 axs x y pi and rx y3 bx px y psi and rx y4x, y, rx 4 axs x y pi and rx 4 bx px y psi and rx